This is First Coast Math Clinic with Lesson 1, Multiplication Properties of Exponents, from Unit 10, Exponents, from our Pre-Algebra and Algebra curriculum. The goal of this video is to use the product to power, and power to power properties to simplify expressions with exponents. So let's just review exponents before we get into these properties. So an exponent is basically used to represent repeatedly multiplying a value by itself. So let's say we've got 2 to the third power in this expression. That 2, that's our base. The 3, that's our exponent. So the exponent tells us how many times you're multiplying the base by itself. Right? A lot of times people get the exponent notation confused with addition. Right? This is exponent is multiplication, so this is going to be 2 times 2 times 2, or 8. So another way we can represent 8 is 2 to the third power with our exponent of 3. Or another example, 7 to the fifth power. So 7 is our base. The 5 is our exponent. So we're multiplying the 7 by itself 5 times. So 7 times 7 times 7 times 7 times 7. And if we multiply that together, we're going to get 16,807. Okay, so that's all an exponent is. It's a way to basically represent repeated multiplication. With our base, and our exponent tells us how many times we're multiplying the base by itself, and our exponent represents multiplication. So I want to review these properties: the product property, product to power, and power to power properties that involve multiplication with exponents. So let's get into these examples. We'll start with the product property. I'm going to go through a general example for each of the properties, and then go through an actual example using some numbers and variables. So let's start with our general example. So if I have a to the m power times a to the n power, well, I've got the same base, and I'm multiplying those bases together. Well, what do I do with the exponents? Well, if I'm multiplying the bases together, I have the same base. All I have to do is add the exponents, right? So this is going to be equal to a to the m plus n power. So my actual example, if I've got a to the third times a to the second, well, we've got the same base here, a and a, so that's going to be equal to a to the 3 plus 2 power, which is a to the fifth. All right, think about this another way. A to the third is a times a times a times a to the second, which is a times a. Well, how many a's do I have here? I have 5, and this is a to the fifth. Okay, so if we see something like this, all right, we're multiplying the same bases. All we have to do to simplify is add those exponents. All right, next property is the product to power property. So our general example, if I've got a times b to the m power, so this a times b is in parentheses, I'm raising it to the m power. Well, how do I simplify that? I can distribute that m inside the parentheses. Now, this is only if we're multiplying the a and the b together, so this is going to be a to the m power times b to the m power, right? So I'm just distributing that m inside the parentheses. So that's our general example. And our actual example, if I've got something like this, x times y to the fourth power, then all I have to do is distribute that exponent of 4. So this is going to be x to the fourth times y to the fourth. And if we think about this, right, this is x times y to the fourth power. So how many xy's do we have here? Well, we've got 4 of them because that's our exponent. So this would be like x times y times x times y times x times y times x times y. So if I rewrite that, well, let's group our x's together. So we can group x times x times x times x. So multiplication is commutative. And then our y's, We have 4x's, 4y's, so this is just x to the fourth, and this is just y to the fourth. All right, so I'm just showing you another way to represent this. And our last property is the power to a power property. So if we have something like this, a to the m to the n power. So in our parentheses, we've got our variable a to the m power, all raised to the n power. Well, what can we do there? We can multiply those two exponents. So here are exponents m and n. We can multiply those together. So that's our general form and our actual example. If I've got x to the second to the fourth, well, I can simplify that by taking our x and raising it to the 2 times 4 power, or to the 8th power. And again, if we think about like what this actually means, well, how many x to the seconds do we have? We've got 4 of them. So this is going to be x to the second times x to the second times x to the second times x to the second. And if we use our product property now, right, we're multiplying the same base. So what can we do with these exponents? X, 2, 2, 2, and 2. We can add them all together. 2 plus 2 plus 2 plus 2 is going to give us 8. So we get x to the 8th. All right, so I'm just trying to show you guys another way to represent this. So let's go through some examples simplifying some exponent problems using our product property, our product to power property, and our power to power property. All right, so let's simplify some examples using our properties. So for number 1, we've got in parentheses u to the third, v to the fourth, times u to the second, v to the sixth. So we can regroup this. You know, multiplication is commutative. We're basically multiplying everything together here. So I'm going to rewrite this as u to the third times u to the second times v to the fourth times v to the sixth. And I'm going to use my product property. We know if we have the same base, we can add our exponents. So our base u to the third times u to the second is going to give us u to the fifth. And then u to the fourth times u to the sixth, excuse me, v to the fourth times v to the sixth is going to give us v to the 10th. Same thing with number 2. Let's group our x, y, and z's together. So I'll have x to the 7th times x to the 3rd times y to the 11th times y to the 9th times z times z to the 4th. So we're using our product property, multiplying our bases. So we want to add our exponents. So this is going to give us x to the 10th, y to the 20th, 11 plus 9, and then z. Even though we don't have a visible exponent here, when we don't see an exponent, the exponent that's there is always going to be 1. So z to the first times z to the fourth is going to give us z to the 5th. Okay, so number 2 is simplified. Let's move on to numbers 3 and 4. So for numbers 3 and 4, we have to use a combination of our product to power and power to power rules and some of our product rules as well. So for number 3, we've got x to the fourth times y to the fifth, all to the third power. So we know that we can start by distributing that exponent of 3 inside the parentheses. So I'm going to have x to the fourth to the third, y to the fifth to the third, right? So I'm using each one of these terms to the third power. Now my power to a power property, I know that if I have a power to a power, I can basically multiply these powers together. So this is going to be x to the 12th, y to the 15th, and that's my simplified expression. Same thing here. So let's distribute that exponent of 2 in the parentheses and distribute the exponent of 3 in the parentheses. So it's going to be x to the second, y to the fifth to the second, x to the second to the third, y to the fourth to the third. Now our power to a power rule, we know that for this x here, there's a 1 there as the exponent. So 2 times 1, it's going to give us x to the second. So we're multiplying our exponents. This is going to give us y to the 5th to the second is going to give us y to the 10th. X to the second to the third is going to give us x to the 6th. Y to the 4th to the third is going to give us y to the 12th. Now we're multiplying these together. So let's regroup this and let's see if we could use our product property. So x to the second times x to the 6th times y to the 10th times y to the 12th. Now if we're multiplying our bases, we can add our exponents. X to the second times x to the 6th. We're going to add those exponents. We're going to get x to the 10th. Y to the 10th times y to the 12th. We're going to add those exponents. And we're going to get y to the 22nd. And that's our simplified expression. Okay. So this was lesson 1, multiplication properties of exponents from unit 10, exponents. If you like this video, leave a like, comment, and subscribe. First Coast Math Clinic.